Just a few words about why we are here and why this workshop is important. So Robotics4eu is a European funded project, European Union funded project, and 3-year project. We have 7 international partners from 6 European countries, from France, Norway, Denmark, Portugal. And our strategy in this project is, on one hand, like Lucas already said, is raising awareness, sharing good practices, transferring knowledge and capacity and community building. But on the other hand is the identification of the most demanding challenges and the issues that arise regarding the social acceptance and adoption of robotics. So this workshop is also serving this aim for us. And what those issues could be, it could be a legal, ethical, socio-economic, gender, you name it, like different issues could be named here. And we raise awareness through this workshop and different events. We are building a platform that will be connecting all the robotic community, and hopefully, and the plan is will be functioning long after the project ends. We are advocating for the responsible robotics, of course, and there is also another tool that we are developing. It's robotic maturity assessment model, which also the results of this workshop will be incorporated in that model as well. So we are not only here community building, but we also here get a response from you. And this maturity assessment model, it will be a tool for robotic solution developers mainly, and to assess their solution readiness or maturity in a way. And the tool will sort of tackle not only the technological part or technological development or how well technology is developed, but also the market readiness and social acceptance and legal issues and ethical issues, it might be so. But more about that, we will show you. Our partner made a video for us about this tool, Anneli Roos from Estonia, Civita partner. And yeah, you will see the short 7 minutes video of her explaining this assessment model more in the detail. So thank you everybody to connecting here today, and we will talk more with some of you in the breakout rooms. Thank you.
Thank you, Diana. And now I think we are going to see a short video.
Hello, I'm Agnès Delaborde. I work with the French National Laboratory for Metrology and Testing, and I'm going to make a short introduction to the maturity assessment model that we plan to develop in the Robotics4eu project. First of all, as you have probably understood, in the project we deal with 5 big issues that we have identified relative to the acceptability of robots. Namely, we have identified ethical issues, socio-economic issues, issues relative to legal aspects. We know that there are many questions around data, and another topic of issue concerns education and engagement of the society. In Robotics4eu, we perform a lot of activities to ensure that we cover a wide spectrum of expressions of interest and issues. We consult the general public, the research community, academics on the whole. We explore also the opinion of the industry, and we also cover the public of policymakers. We have carried out many events, and some of them are currently ongoing. Our final objective is to design an assessment grid that will help people to understand to what extent and through which means the robots can be accepted by society. A mature robot, what we can call mature robot, or a mature design process, this has to be defined. It would then earn some kind, the robot or the process would earn some kind of a label that would to some extent represent the level of maturity, some sort of a score of maturity that could be easy to understand and above all that is useful for all the concerned stakeholders. We've got one first question. We want to understand how this scoring can be performed. Shall it be external inspectors that analyze, explore the robots or the processes and provide a score this level of maturity? Shall it be the designer himself or herself who compute the score of maturity before, for example, selling the robot? Shall it be the end user, so the person willing to buy the robot or to use the robot, who shall perform this computation of the score? It's still an open question. We also wonder about the type of tools that we need for estimating the level of maturity. Shall it be questions asked to someone, to the designer, for example? Shall it be some kind of measurement? Shall it be also, I don't know, any type of scoring, in fact? So all the tools to carry out a proper assessment of the maturity need to be explored. So this is what we do in the project to understand what are the tools to do that. We also want to understand what is a good score of maturity, depending on what context, for what objective, for what goal in the end. Is it important that all robots have a good, perfect score of maturity, or does it depend, for example, from the context of application of the robot? This is another question that we are trying to solve in the project. To give you an example, so far we have carried out several consultations. We focus on these three aspects. What are the tools? What is really the score of maturity? What does it mean? And also, who are the stakeholders around this score? We obtained some initial insights about the topics. Concerning the tools, we understand that there is most of all a need for identifying and designing what we can call estimators. So everything that, well, when put together, can provide us the score on the whole. Concerning the score itself, one thing that was really important is almost everyone agree on the fact that the score must be a reward, not a punishment, meaning that a low maturity score should lead perhaps to some enhancement of the robot, but not a punishment, not something telling you that, no, the robot should not go on the market because the score is too bad. So you see here the overall idea. We want to be useful. We want this score to be useful. Concerning the stakeholders, a few words about them as well. Apparently, it seems that it will be interesting for end users, the person who are really going to use the robot, but also for supervision entities. It makes sense that it is computed by the producer, so the designer of the robot, and it can also be performed by a third-party auditor as well. To give you an idea, concrete idea of what could be this maturity assessment model, it can take the form of an assessment grid. Here we see a real Simple, a really basic example. So for all 5 domains that we identified, it can be checkpoints. And the question is, first, well, what should be in these checkpoints, but also what can it be? What can the score be? Shall it be a pass, fail score? Shall it be, well, something a bit more subtle? In any case, it must be a guidance so as to improve maturity. In the project, we still have a lot of consultation ongoing. We still need to gather a lot of references. We don't work alone. We need to know what are the other good practices in the community. So sharing knowledge will be really important for us. Thanks a lot.
Thank you. So that's a little bit about the Robotics4eu and their assessment model, maturity assessment model, what they are working on. Keep these ideas in mind, since we have a few questions at the end regarding the maturity assessment model. And my name is, by the way, is Lucas. I'm the moderator of this event. I am based in Vilnius. I am a freelance science and technology journalist working on radio and TV shows here in Lithuania. My radio show just aired 20 minutes ago on Žinių Radijas, Dubitai, where I weekly talk about technology news. I also work on the popular science TV show Mokslo Sriuba, and we were filming in Kaunas, in another city in Lithuania, 2 days ago, where I filmed the first robot spot, the Boston Dynamic robot dog spot in Kaunas. We had a great time, so we are working on this material at the moment. So yeah, I'm here to moderate the event. If you have any questions, you can ask me. You can ask it in the chat. We have a chat that is very easy to use. If you have any questions, if you have anything to add, let's talk here. I'm writing it down now. There are also some usable functions in the Butter app, for example, reactions, and the agenda is all here. I think it's quite easy to get around. And this creative workshop is going to last 3 hours, and it is divided into 3 parts. So first of all, we are going to start with a brainstorming session where you will have to answer some multi-choice questions and some open-ended questions also. Afterwards, Dr. Artur Bogutsky will give his presentation on the non-technical challenges of robotics. We'll also have Dr. Oscar Marco presenting a case study, how robots are revolutionizing blueberry production. And after that, we are going to do some work in groups. We are going to have a coffee break, and Dr. Soren Markus Peterson presentation on social impact of robotics will finalize our event. I guess the presentations is something that we are all very much looking forward to, really to learn something from these amazing speakers, and I'm very grateful that they are here today. But first of all, as Diana and her colleague presented, Robotics4eu wants to know a little bit more about you, so we want to start with an initial survey questions. We want to ask you some multiple choice questions about your involvement in robotics and what do you do with it. So please, everyone, if you have your mouse ready, let's start with the initial survey. Maybe you've done this before, but we want to gather some information about you. So we have 5 questions, and it's multiple choice, and you can agree, fully agree, you don't know, you disagree, or you fully disagree. And the first question we want to ask you is, do you interact with robots in your environment? I can see you're already working. Let's do it quickly. I guess it works quite smoothly, like a butter. Okay, I also vote. I can see the number of participants voting. So we'll have the survey in the beginning and at the end of this event, so the organizers can understand better how it's going out for them, how everything is working out. Hey, I can see only 11 out of 30 of us have voted here, so hopefully you're coming back to your computer or phone now at the moment. Yes, there are a few more. I'll wait a few more moments. Also, yeah, there is someone still voting. Okay, there is half of us. I'm pressing the submitting. Let's see. Yes, most of us work with robots in our environment, but not all of us. So I'm closing the poll. Let's do the second question. Let's do it quick, so I think it's quite easy. Whoops, the poll is out. Second question is, I interact with robots in my home or personal environment. So it can be, I don't know, vacuum cleaner robots or other robots maybe you have at home or your personal environment. Do you? I have to think for a moment myself. So let's vote on this one. And okay, I'm submitting my vote, and we can see already the results, right? So fully agree or agree are the most common answers. So we do have quite a lot of you do have robots in your home or personal environments. Okay, our third question. Let's move on. I believe I am aware of the main non-technical issues that the robotic industry faces. That's a tricky one. I believe I am aware of the main non-technical issues that the robotic industry faces. So that means that you know the robotic industry and you know the non-technical issues that they talk about and they face. I'm voting too. Yes, and as you can see, we have the most popular answer is agree. So yes, you do understand what are the issues and the problems and what the people talk about. Great. Our fourth question is, I'm not sure if I should put the close down the poll. Oh, sorry. My bad. I closed down, but we have colleagues working on this and they are helping me. Our next question is, I believe that various aspects of robotics are discussed sufficiently in the public discourse. That's an easier question. Okay. I often say that if I get a 1 cent for every time I read an article about if the robots are going to take our jobs, I would be quite rich by this moment. So that's just my opinion. Hopefully, don't want to move you too much. I'm voting. Nice. We have more participants now voting, which is great. Okay, most of you agree that various aspects of robotics are discussed sufficiently in the public discourse. Let's see our last multiple choice question, which is, technological progress is more important than social progress. I guess you would like to discuss this one with me. It's an open one, more of a philosophical one, but if you have to choose, and let's choose this for this moment, technological progress is more important than social progress, however you understand the question. I'm also voting together with you. Yes, and we can see already that most of us disagree with this statement. Okay, one more moment for us to finish voting. Great. Okay, great. So thank you very much for participating. The disagree is the most common question, and we'll have some time to, in our teamwork, we can discuss these questions. And if something surprised you, you can keep it in mind, and we'll talk about it. Okay, so I'm closing down the poll. Thank you very much for participating. Now we have a little bit trickier part, a brain-writing session, and there are going to be a few open-ended questions. And you can also vote for those questions. If you like someone else's answer, you can vote for the answer. So let's do the brain-writing session, and there are a few tricky questions here too. So the first question is, what are, in your opinion, the main socioeconomic issues in the adoption of robotic solutions in agri-food industry? So that's a tricky one. If possible, try to keep it short. If no, go with it. When you type your answer, you can then see the other answers and you can also vote for them. So first of all, you have to think of your answer. What are, in your opinion, the main socioeconomic issues in the adoption of robotic solutions in agri-food industry? I'll type my question in a moment. My answer, I mean. Okay. I am typing my questions and hopefully answer, and hopefully you are too. I am submitting my answer, and now we can see the answers if you already voted. And you can vote for your favorite answer. I'll read some answers out loud, so maybe you're typing and you can then agree with someone else. Restructuring workforce is one of the most popular answers at the moment. Knowledge and money, legal issues, killer robots, of course, great answer. Acceptance of robotic solutions, inequality of resources, acceptance of new technology, monopolization of the sector due to uneven adoption of technology and high barrier of entry. I like this one. Okay. Great. A few more moments. And these are the questions that we are going later to discuss, as I mentioned, in our teamwork. We're going to have around half an hour. We are going to go to breakout rooms and discuss also what you do in the robotics and what issues do you find here and how to overcome them maybe. Okay, let's finish this question and we'll see the most popular answers. Yeah, the most popular two are restructuring workforce, so the need to restructure workforce for adaptation of robotics, and also the monopolization of the sector due to uneven adoption of technology and high barrier of entry. Great, that's a great one. Thank you very much for your great answers. Our second question is, what are, in your opinion, the main ethical issues in the adoption of robotic solutions in agri-food industry? So before we had socio-economical, now we have the ethical issues. Are there any? Can you think of any? Everyone is thinking and writing their answers now. Let me think for a moment. Okay, I had to think for a moment. Hopefully my chatting doesn't interrupt your answers. Let's submit our answers and let's vote for the best answers. There are quite a few of you who write I don't know, and that's definitely okay. Let's see what others have to share with us. Some interesting answers, a few of them having to do something with human labor and re-educating the workers. The one answer is talking about balancing human-centric nature and then environment-centric solutions. Yeah, and some other answers are quite have something similar to say, taking workplace from humans, data security, AI choices and scenarios of accidents, unrealistic and conflicting goals. That's a great one. I haven't thought of some of these answers, not at all. So let's vote for your favorite ones, the ones that you agree the most. Okay. Okay, let's close this question and see the most popular answers. And there are quite a few. It looks like this is an interesting topic to talk about. So, substitution of human labor. What to do with the unskilled workers is a popular answer. AI choices and scenarios of accidents, balancing human-centric and nature environment-centric solutions, unrealistic and conflicting goals. Great ones, great ones. Some I haven't thought of at all. Let's move on with our third question. So the question is mostly the same. Now we are talking about legal issues. So what are, in your opinion, the main legal issues in the adoption of robotic solutions in agri-food industry? Let's talk legal now. Are there any? Can you think of? It would be really interesting to hear from someone who has actually had legal issues in the adoption of robotic solutions. I'm thinking of answering myself. After you submitted your answer, you can vote for the one that you like the most. Someone in our group is really interested in data protection. I can see the answer in some of the questions. Data security, yeah, it's a popular answer. Government not making clear laws about it. Okay, one of the answers. Actually, I don't know if you know, but there are a few new laws in the European Union being ruled out at this moment. Just some background information when you're voting. The two of them. About them in my radio show. Just don't remember the English name for it. Yes, so the names are. Yeah, the Digital Services Act and the Digital Services and Digital. What's the name of the another one? Skaitmeninių paslaugų aktas, I know in Lithuanian. If you don't know about it, maybe it's interesting for you also to learn about it. We can discuss it. Okay, it looks like most of us voted. Let's see the most popular answers. What do you have to share with us? Licenses for data sharing and handling. Who is responsible for data protection? That's the most popular answer. Data security. The imbalance in contracting between precision tech providers and farmers due to information asymmetry and loading the problems in data ownership. Government making clear laws about it, and political and legal decisions are slow. Great. It looks like we are agreeing on this one. Let's move with our next question. A few more left. What are, in your opinion, the main issues regarding data management in the adoption of robotic solutions in agri-food industry? That's quite a specific question, but I saw your answers discussing data management in previous answers, so hopefully you have something to share with us in this one. I have to admit, I have no idea on this one. Not something I can say a lot about. So looking forward to your answers. I can see it's taking you some time, which is okay. Don't hurry. Think of your answer, and after you did, you can vote for other answers. And the name of the law I wanted to mention you, maybe you're interested in that, is one is the Digital Services Act and the other one is the Digital Markets Act, which are quite a new laws being pushed out in the European Union just while we are voting. Okay, we have quite a few answers. I am voting too, and in a few moments we'll see the most popular answer. Standards will not do the trick. Okay, the most popular answer is cybersecurity, and no legal background established of those apart from upcoming EU data and the EU Data Governance Act. Standards will not do the trick. So these are the top answers. Okay, let's do a few more and then we'll finish. So our next question is, what are, in your opinion, the main issues regarding the educational and engagement processes in the adoption of robotic solutions in agri-food industry? I'll just shut my mouth for a moment so you can read yourself. Maybe it's easier to understand the question then. Let's put our answers in. It's a broad question in a way, depending on how they understand educational and engagement processes. But let's try it out. I think we'll have different opinions on this one. After you voted, vote for the answer you like the most. Oh, we have quite a lot of answers. Okay, let me vote. Okay. I guess most of us have voted. Okay. Some interesting answers here. I think we can also discuss this later. Okay, so let's see the most popular answers. Education programs for new types of jobs. Okay, the most efficient solutions are kept secret as long as they can to maintain a market edge plus costs. People do not want to change, lack of interest and acceptance. It is not always clear how digital data and protection is related to robotics. Great, thank you for your answers. This was an interesting one. Let's finish with our last question, which is, what is, in your opinion, the most important issue area in, of course, the adoption of the robotic solutions in agriculture area? So this is, you don't need to answer. It's not an open-ended question. You just vote for the one you agree with the most. What is the most important? Which one is the most interesting to you, for you to think about? Okay. Which area in the adoption of robotic solutions in agri-food industry do you find the most important? Okay. I think we have most of the answers. And a strong lead is the answer: socio-economic issues. So I think we can close the winner. Socio-economic issues. It has 7 votes. Great. So now, thank you very much once again. Thank you for your answers and for your ideas. And it's now easier to understand what are we all talking about. We are going to have a similar questionnaire at the end of this event, but now we'll go on with our presentation. And the first one is going to be Dr. Artur Bogatsky, a research assistant at the Center for European Policy Studies, which is a think tank, and also an assistant professor at Warsaw School of Economics. He is going to give us a presentation about perception as a factor in agricultural technology implementation. So we are all very much interested in what Artur has to share with us. So Artur, hi once again. Can you hear us and are you ready? I've been talking with myself for quite a long time, so hopefully you are here and you can hear me and you are ready to take over. Artur, are you?
Absolutely. Thank you for having me.
Great.
I'm just trying to share the right screen right now.
Okay, don't worry. Take your time.
It's always the issue when you have more than one.
Yes, I know. This time I only have one screen, so I can even feel it's easier than having a few.
Okay, maybe let's change things a bit. I
Yeah,
will
because we
move
see
my presentation to my big screen and change the...
Okay.
Yeah. Does this work? Maybe. Oh, no, it doesn't.
It's quite small, yes, because your screen is quite wide. It's a wide screen.
Arthur, maybe try sharing the window only. There's a possibility when sharing the screen.
Okay, let's hang on for a moment while Arthur is figuring out the screen. Yes, now I think it's going to...
Now we have the laptop screen, right?
Great, but it works, right?
Yes.
So it should be fine.
Yeah, it's fine. It's fine, Arthur. Now just make it through.
Yep. Does this work?
Yes.
Yeah, I'm so sorry.
Don't worry at all. These things happen online. So the stage is yours. We are listening.
Thank you very much. So thank you for having me. I'm honored for the invitation. Thank you for also talking about my background a bit. I am a lawyer and economist, also pursuing a background in neurosciences, cognitive neurosciences, and I am involved in empirical studies on experimental studies on the perception of technology, mainly digital technology, but as well robotics. How does those things mix up? It's usually whenever you have, for example, an AI system which resembles a human, for example, and how people react to it. So it is an interesting challenge to talk about this issue, considering how uncharted territory it is, I would like to go through it and actually show to all of you the current state of affairs and suggest maybe a few paths forward. I am also drawing on some developments that me and my colleagues from SEPS developed on FlexiRobots project, which is a project that Oscar, who's also a speaker, and I represent today, which is a project for running 3 very interesting pilots. All of them apply precision agriculture technology to different types of crop harvesting, but I'm sure I'm sure Oscar will tell all of us in details more about what we do on FlexiRobots. But what we do at SEPS is exactly ethical, legal, and socio-economic aspects of applying precision agriculture. So let me start a bit and talk what maybe show what I'm going to talk about today. So the agenda is I would like to start what the perception is and what is its role in the adapting of innovation. And I would argue it is as important as the ethical, socioeconomic, and legal issues that we like to talk about. And I would like to present also some arguments from the literature or lack thereof, why it shouldn't be this way. Also, then we would move to existing models of technology adoption, then talk about the subject themselves for a bit, mainly robots. Then I would like to present the state-of-the-art study and what it entails for this topic. Then we would draw some perceived advantages and perceived disadvantages of applying robotics to agriculture. And then I would like to move to proposing an adaptation of another model, which is a voltage effect model. It's a game theory model. It's quite a novelty in the behavioral economics literature. And then I would like to draw some conclusions on it. So let me start, because as you probably see, it's most likely overly ambitious agenda. So let me time it. So the first one, introduction to perception and what its role. So as I've mentioned, we like to talk about ethical issues, technical issues like coding and AI issues, deep learning issues, robotics, legal, data protection. But when most people think about applying this technology for it to work, the perception and the behavioral aspect of how does it happen is usually neglected, and especially neglected in this area. As you can probably see, we can safely assume that applying robotics to field crop actions can yield sustainable intensification. But of course, for them to do so, they need to be accepted by a sector and markets within it. So who are the stakeholders? Like farmers, distributors, contractors, of course, society and policymakers. Today, I would like to focus on farmers, and probably mostly, and how they are the most important ones in actually making it work, and especially in the context of the projects we are running. How could we scale this idea? So we know that the individuals in all the models of technology adaptation are at the center, but we also know that the business to business and decision makers issues are the most vulnerable pieces in a chain that determine whether we actually adopt the technology or we dismiss it. And those are the gatekeepers who, unfortunately, based on literature review, happened to have a say at the key milestones of the innovation process. So in order to scale the idea and make it adaptable, we need to actually know how the gatekeepers feel and perceive certain issues to maybe change this perception or change the idea to fit the perception itself. So this would be for the introduction, and then quickly move through the models part. What are the models and why they usually do not work, and why in my view, I would like to argue that we are doing the empirics on technology adaptation a bit wrong, a bit from the other side. Also, this would be connected to our ongoing replication issue in social sciences. So in order for our models to not look like the previous one, we have existing models that include psychological factors. Of course, there are a lot more models, but those ones actually care about how people perceive things. So it's from the more behavioral side, not neoclassical side. The first one is the technology acceptance model. You probably all know this one. Used for the acceptance of AI, IT systems, which it is based on the theory of reasoned action from the while back. And it's used to understand the acceptance of behavior associated with new information technologies by using psychology input and cognitive neuroscience input to measure attitudes and subjective beliefs. Because one thing we need to establish is that we are very much prisoners of ourselves. That's why subjective beliefs. Then, theory of planned behavior is an adaptation of the technology acceptance model, adopting the supplementary component of perceived behavioral control. Then the model was very much refined through adding social influence, trust and risk. It's of course not perfect, as it's not including any emotional, social, or cultural components, which we know now in 2022 are absolutely crucial for determining behavior. The last one I would like to mention is the 5-star model of innovation, of course, which includes decision processes based on measuring knowledge, persuasion, decision, implementation, and confirmation. So it includes psychological factors of personality, attitudes, of uncertainty, as we've talked, and of course social norms, as these are crucial. But we have all these models, but they do not really come to anything bigger than that. So they all promise or recognize factors that influence technology acceptance, but either research on managerial judgment and decision making, nor the more advanced models do not produce any comprehensive framework for measuring this and measuring application of the technology itself. So it is also an issue not only on the individual level, but also on the corporate and collective level. We know that those gatekeepers are actually quite more difficult to get on our side whenever they are in an organization, because, for example, as the literature shows, those decisions are mostly based on merit and also impose additional friction and cost on decision making due to costs as the pursuit of maximization of profit is a burden in this context. Then let's take a quick look at the robotics we are talking about and what we are actually perceiving. So we have small robots, which are usually quite eco-friendly. They can operate in swarms, they can fit individually, and they actually are perceived quite well, as we will see in the next slides. They are usually used for weeding, harvesting, spraying, sometimes small tractor operations. Then we have large robots, autonomous tractors, for example, which can do a lot of stuff, really heavy lifting. And these are not so well perceived, which we'll come to next. So what is the current state of our knowledge on the farmer's perception of field crop robotics right now? So the issue is that we have very little, extremely little data on the subject, as this is a very much still growing field. But we have some overview which I can go through quickly. That, for example, some experts from California suggest that economic factors may both drive and hinder adoption of robotics. Another interviews indicate concerns about reliability and cost efficiency of data storage. Cognitive factors such as a lack of trust in robotics decision making may impact how we adopt this technology, as well as we should definitely stress out that there is an enormous research deficit, especially outside the US. The literature is nearly not existent right now. So I would like to, for example, point out that there was a study conducted on literature review in this field, which only found 18 acceptable papers, which could actually share a light into the social economic sphere of this issue. So those are things that we can agree on, but there was a survey conducted by Röpke von Hattelheim and Hesse in 2020, where they predicted that larger fields will adopt field crops robots sooner than farms with many small fields, irrespective of total acreage. They followed up this study with a survey which probably you're aware of, and distinguish three clusters, which are quite important, I believe, which are convinced adopters, open-minded supporters, and reserved interests, all of which has an impact on how and where this technology would be adapted. So the publication trends I already mentioned to save on time, because I see I'm already well off. So we can distinguish a couple of effects that are perceived by subjects, which are economics effect, an environmental effect, and social effect. So economics effects, for example, literature points out to switching from whole field to precision approaches associated with increase in net returns, which is important, obviously, but for example, study shows that it's less important for smaller farms than for bigger farms. Small-scale field crops appear to be economically subsidies for labor, especially beneficial for organic farming for many reasons. So these are the economic effects, all based on literature. For example, autonomous weedings operation outperform conventional tractors on small rather than large farms. which farmers would need to take into consideration when actually making a decision. Then we have environmental effects. For example, small robots reduce the negative impact of cultivation processes on soil structure and biota due to the low weight, and so on and so forth. Then they would need to consider social effects, like for example, how does the application of the technology impact our workforce? For example, can it cut on stress or physical strain, as literature suggests? And is this factor important enough for farmer, for example, to actually invest in the technology? So many social effects, and there are very little available perception studies. As I've said, only 18th in last 30 years actually are usable and actually are gathering data, most of which in the last 3 years. So in the one study, I would like to present some conclusions. 22.6% of people actually farmers plan to invest in the technology within the next 5 years. This would be relevant for my last slide. So please keep that in mind. So only the farming system significantly influences participants' plans on investing in field robots. So the empirics show there is not much actually wiggle room to consider this. And I actually very much am of opinion that this is only due to the extraordinary lack of data. So what are the perceived advantages by farmers? So as I've said, reduced soil compaction is viewed as a great asset for field crop robots. Several economic advantages also follow, pointing to the possible source of motivation in case of purchase of field crops is considered. Of course, a preservation of small-scale landscape as a social aspect was rather present, but not as important. And actually, most of the social aspect, like possibility of treatment on individual plants, as well as possibility of intercropping, not as important as we may have perceived before. So, for example, this is the graph on data on perceived advantages. And as we've seen, if someone sees something as rather important, it actually shows how already willing they are to invest in the technology. Then we have, of course, perceived disadvantages, which we've mentioned at the beginning of our workshop, which are unresolved liability issues, for example, and market maturity, of course, which are found to be the biggest issues, especially for more corporate-like farmers. As well as we have a lack of compatibility with older technology, which of course implies costs. And actually another psychological importance is that it is shown in literature that farmers would not like to lose attachment to their farm, and for example would like to be able to repair the tractor on their own. If it's an autonomous tractor, of course, it's impossible. That's why this is considered an disadvantage. So these are the perceived disadvantages.
Yeah, Arthur, yeah, I'm joining in you. Yeah, it's can you maybe do the wrapping up of the presentation just to not take too much time for the presenters?
Great. Well, so I hope the main reason I would like to talk about this is the change of the approach, and I would like to talk about a voltage effect, which is a how to scale ideas. And why is psychology and perception important in this part? Is because it's actually all about that. It's all about the data and all about how we conduct experiments. So what is a voltage effect? For those who doesn't know, it's a approach of 5 vitals of scale, which we need to check firstly before we implement an idea. So if we would like to modernize the agricultural sector, the first thing we would need to do is to actually acquire empirics on the topic. So there are no silver bullets for applying such an innovative idea, because whenever we do so, whenever something works at, for example, one of our pilots, even if it's a spread out one, it would not. It could not work at scale because of the voltage drop. Some things could not work, for example. And the thing to beat it is to find the weakest link. So in short, the 5 problems are inference problems, so false positives. If something works it's just basic statistic. If something works during one of our pilots, it could not work at scale. So we need to replicate. Then representativeness of population, so overestimation as well. We need to know what the farmers, and not only farmers in Europe, for example, but in general, think about this issue, to target it specifically. So not to compare, for example, farmers in Serbia to farmers in Spain and see the differences. No, we need to know what all the farmers think and scale on that. Then we have unscalable ingredients. So for example, we have very much lesser issue here because we are trying to scale technology. But it also implies if the scaling of technology works only because our pilots were run by 20 AI PhDs and an army of data scientists, then it wouldn't scale at all. So people are not scalable. Then unintended consequence and spillover means that we are arriving at different market equilibrium after we scale. So the things we're trying to actually attain and create by going big with a project could actually come to a completely different reality. And then, of course, we need to consider supply side economics, so marginal cost consideration. Is it even feasible? And literature shows very clearly that in best case scenario, like 1/6 of farmers who are actually consulted on this are willing to invest in small robots, not the big ones, in the next decade. So even if we scale it, would it be applied? So I'm just closing.
Arthur,
Suggestions.
yeah, I think we definitely have to
Absolutely.
wrap up the presentation. Yeah.
So background induction, go from scaling to pilots and use project-based data, know your audience, and do not interview only the enthusiasts from the farmers. Consider heuristics and biases in innovation, so all the status quo biases we've mentioned already, so on and so forth. Remember that humans do not scale, especially in the technology department, if technology needs high qualified people. Spillovers to new equilibriums, what happens to farm activities afterwards, and of course avoid these economics of scale because it wouldn't work. Thank you very much.
Yes.
And sorry for it being too late and too talkative.
I think it is an ambitious topic you took, but thank you very much for your presentation. Really great insights on the topic where it's not so much data as you mentioned. So thank you, Arthur, once again. Let's not have the questions now. Let's move on to our next presentation since we have something to hear more. So next is agricultural robots revolutionizing blueberry production, and it's going to be a study case from Oscar Marco, Assistant Director for Innovation and Collaboration with Industry at Biosense Institute. He's from Serbia, but now I think he's in Bratislava. We talked shortly before joining. So Oscar, hi, and we are listening to you.
Hi, Lucas. Thank you very much. And first of all, thank you very much for inviting me here, and to Thomas as well. It's a pleasure to speak with you on these important topics. So I'll speak about robots in blueberries in Lithuania and Serbia, which is a use case from our Flexi Robots project. Hopefully you can see my screen now. But I will not just talk about the project. There is, can you see the screen?
It's all good.
We can see it.
Okay, brilliant. So I'll speak about precision ag in general and robotics in general. So as Plato would say, necessity is the mother of invention. So this is the task that we have in front of us. By 2050, there will be 10 billion people on this planet. And in order to feed this growing population, we need to increase the food production for 70%. And to do that, there is a wide variety of technologies that we need to develop. So starting from the sensors to remote sensing, drones, IoT, and robotics. And all these are basically just platforms for gathering the data. And once this data comes to the cloud, that's where the magic happens with big data analytics, machine learning, and artificial intelligence, helping our farmers to be more efficient. So what do we want to achieve here? We want to increase the profits. We want to have the planet saved. And well, in one word, we want to be sustainable, to take care of the people, planet, and profits. And that is the reason why we're doing this in the first place. So the first question is where to innovate in robotics and in precision ag in general. And we had an interesting project with K+S, which is a fertilizer company from Germany. And we were thinking that we're going to do something marvelous for Germany, for the US, etc. But they said, oh, well, the maize yields, for example, are already something like 20 tons per hectare in Germany and the US, and they can be maybe 22, but, they're not going to be 100 tons per hectare. Whereas in Uganda, where we also have a project, maize yields are 500 kilos per hectare. So it really matters what geography where you're working with, and what kind of robots you want to apply, and what kind of things you want to achieve. Whereas in Africa, for example, you want to increase the production. In Europe and America, you want to decrease the need for the labor. So we have a number of these clear path robots. We have also another robots which came through Flexi Robots project. And what these robots do in general is that they're picking the fruits and vegetables. That's one thing. The second thing is that they're allowing us to spray, or rather target spray, our fields. And also there is an interesting example, which is the hands-free hectare in the UK with Harper Adams University, where there was 1 hectare of wheat where no human has entered the field for a year. So they had automated tractors, combine harvesters, drones, satellites. So they use all the technology to produce wheat, and they managed to do it. All the problem now is that this kind of production is quite expensive. So we're on the verge of a digital revolution in agriculture, but I think that the main problem behind the scaling and behind the uptake is the unknown, or maybe not very beneficial return on investment. Because it's easy when you're producing, for example, pens. So you take a bigger machine and you produce twice as many pens as you could do before. But with agriculture, you can't really say how much more you're going to earn if you use robots, how much more you're going to earn if you buy a UAV. So it's not that simple, and that's one factor that is hindering the uptake of this production. The second thing is that I think that this change, although it can be dramatic in technological terms, in terms of socioeconomics, it needs to be gradual. So one thing to overcome that barrier is to use farm management information systems. And the one we're running is called AgroSense, but there are many, many more in Europe. And I think that if farmers can use Facebook, and 70% of Serbian farmers are using Facebook, well, then they can use farm management systems as well. So we launched AgriSense in 2017 with the idea to get farmers to try to digitally transform their fields and their production, and there was a lot of success with this platform. So we have more than 20,000 users, and the total area that they're operating or managing through the platform is equal to 1/4 of all Serbian farmland. So I think that this step is the prerequisite for using any kind of digital technology. So they need to understand what's happening. They need to be able to take a look at some simple things like weather forecasts, like satellite images, and it needs to be quite intuitive and simple to use. Well, the reason why we chose blueberries for these products is that they're quite promising. So they're quite high value crop, meaning that you can earn up to 40k per hectare, which is quite a lot. And also there is a saying that blueberries are something to leave for your grandchildren because they grow 50 years. There are two use cases that we analyzed. One is in the outskirts of Belgrade in Serbia, and the other one is in Kaunas region in Lithuania, which I'm sure most of you are quite familiar with. So these are hilly terrains, and they're perfect for growing blueberries. But the thing is that these two terrains are on the southern tip and the northern tip of the region in Europe, of the climatic zone where blueberries can be grown, meaning that the farmers are able to achieve highest prices at the beginning and at the end of the season. There are actually 4 use cases that we are analyzing here. So the first one is monitoring, where we're using UAVs and satellites to really understand and see what's happening on the field. The second one is soil sampling. The third one is detection of weeds and diseases. And the last one is action, which is in this case spraying and lab analysis of the soil. The holy grail of robotics in agriculture is, I would say, picking fruits or vegetables, because it is the most tedious job for which you need the largest number of people to do it. But it's also very, very far from practical success. So we wanted to be as efficient in this project as we could, and to really complete and have ready solutions for the industry. So speaking of blueberries, there is this wide gap between the practitioners or like researchers and the scientific community and technicians and farmers, and also, you know, some people, when you say blueberry, they think of the comic. Some people think of fruits, and it's really hard to have a successful marriage between the two sides. So you really need to understand how farmers are thinking, how technology developers are thinking, and to be there right between them. So soil sampling is one very important task because it takes a lot of human labor. So in order to sample the soil on 1 hectare, you need at least a day, and that's a very optimistic calculation. And you need to sample it as many as 12 times per season. So this is a lot of time and a lot of work for the farmers, and that's one of the things that we managed to automate. So this is the robot, and there is this huge machinery on top of it. And so the first thing there is to use UAVs to delineate the management zones. Then there are the points that need to be analyzed, which are inferred by the artificial intelligence algorithms. And then this robot is sent to the field. So there is a Muslim saying that if the mountain won't come to Muhammad will come to the mountain, which basically means that here, instead of taking the soil samples to the lab, we took the lab to the soil samples. So we reversed the idea around, and it's performing quite well. So you're getting the samples and the analysis automatically, which allows you to have automatic adjustment of your decisions on the field. So this is like this NutriBullet or something that you use for making the orange juice, but it's also just for stirring the soil in the water and analyzing it with optical techniques. There is also a zone delineation. There is also the same thing with satellites, so that you can really get to know to which points you need to send the robots and where to analyze the soil. So the second thing that we analyze are plant diseases, and there are a lot of them in blueberries, and they can cause a lot of damage. So they need to be sprayed. Well, the first thing that UAVs are doing is that they're localizing the weeds across the field, and then they're localizing plant diseases. So, for example, in this picture here on the left, you can see that there are 3 or 4 rows that have been affected by plant diseases. And these rows are those that need to receive the pesticides, or release higher amounts of pesticides than the rest of the fields. So it's also target spraying, which allows us to save money because pesticides are quite expensive, and you're probably observing what's happening with the fertilizer and pesticides prices. So the gas prices have risen, supply chains have been affected, and hence the fertilizer and pesticide prices have tripled in the past few months. So which is a really bad thing for the production. But there are also some optimistic sides here, because we will be saving more and more pesticides. We might even transit to organic production, meaning that we will have healthier products, and that we will pollute the environment less. There are also AI algorithms here, which are used for detecting the rows. So you can see here a blueberry field in central Serbia. You can also see the rows that have been detected, and when you align them with the blueberries, you know exactly how to analyze this image and how to detect weeds and diseases. So it's, as usual, there are 3 steps here: detection, assessment, and action. So we're detecting weeds and diseases, we're assessing these plants, and then we're posing actions. And you can see here that we're not using just robotics, we're also using sensors, we're using LoRa systems for communication with the sensors, we're using farm management systems. And I think that this kind of holistic approach here, with optimization of fertilizer, irrigation with the robots in the fields and UAVs, is the way to go, because I don't believe that any single technology has the power to digitally transform agriculture and to make it more profitable, less risky, and more sustainable. It is a huge task for all of us, and it needs to be attacked from many, many different sides. So, for example, here we're also using information about the soil moisture, about the rainfall, about the sunshine, and everything else to optimize irrigation. And these robots are equipped with different cameras, with multispectral cameras, with LiDARs for 3D point clouds and autonomous navigation. There are UAVs here, different vegetation indices telling you whether the plants need to have more nutrients, or whether they need more water, where are the parts where they're growing better, where are the parts where they're growing worse, etc. And I think that what we're building here is essentially a layer cake. So what big data is actually many, many different layers of data, like vegetation indices, like UAV images, like satellite images, like irrigation information, etc. Soil information as well. And I think that you really need to have this kind of holistic and interactive approach with the farmer as well, to analyze all parameters. And I think that there is a reason why these systems are usually called decision support systems and not decision systems. So we're still not kicking the farmer out of the equation. We're still just helping farmers optimize his or her decisions. And I think that this is what robotics and big data analytics are about. So that tomorrow we can see more farmers like this one with laptops and tablets and mobile phones, and farmers which are more sustainable, less risky, and more profitable. So thank you very much. I think I'm on time, and yes, I'll stop sharing my screen. So I might bombard you with a lot of information, but I think that this kind of diversity in data and algorithms and approaches is what we need at this moment.
Yeah, well, it was definitely worth the listening, and there was a lot of information, but super, extremely interesting, the study case. So thank you very much, Oscar.
Thanks.
And I have a question for you, but does anyone has any questions for Oscar? We still have a few more minutes to do a Q&A. So if you have any, you can write it down in the chat. If you feel like, you can just connect with your camera and your microphone and do it. So if not, I'm just wondering, at what stage of this project that you just told us about, what is actually now, what they're doing with it? I think I maybe wasn't the only one in the beginning not to catch it. So where are you now in this project?
So we designed everything and we started building the robots, and we have the prototypes for some functionalities. So we took the robots out for a walk this month, and we managed to have some initial experiments with sampling. So this automatic process will probably work very well and even a bit faster than we initially thought. So we developed the soil sampling module, and right now we're working on the drone spraying module, which is the second major development that we need to do.
Great. And are you looking for any I don't know, teamwork or collaborations with other experts in the fields, or are you looking to commercialize it in the next future? So for those who listen to you can understand what are you up to next.
Of course, thanks for the question. I think that you brought it up quite well. Well, as I said, that there needs to be a holistic approach. I think that there also needs to be a holistic approach in the community. We are a research and development institute, but I don't think that we would go far if there wasn't for farmers, because engineers usually have a tendency to invent problems for the solutions they have. So I think that it's time to reverse that as well, to have farmers and to really listen to them. And also in terms of the technical development, I think that it is also good to have robots that are doing multiple operations, and that's one of the things Flexi robots is about, to have flexible robots performing multiple operations, because if you just have a harvesting robot, you're going to use it once a year or maybe a few times a year, but it's going to sit idle for the most of the year. So I think that it would be good to join forces and to have really flexible robots and to have robots that farmers actually need.
Yeah, and do you feel that someone else is doing something similar to what you do, like these kind of study cases, maybe not on blueberries, but other agriculture, or do you feel like you're alone in the field?
Well, even within this project, there are also some really interesting use cases with vineyards in Spain, with oilseed rape in Finland, and there's also, you mentioned small robots, and there is also the small robot company from the UK, which is also an interesting example how a fleet of small robots can help in the fields without compressing the soil. So I think that AgTech is a really hot topic even in the startup ecosystem and across the world in general, and that there are a lot of interesting solutions, and that we live in quite an exciting time, and that we will in a few years see a lot more robots on our fields.
Great. So thank you very much, Oscar. Thank you for a great presentation. Amazing things that you do. Will be interesting maybe to hear you in a year or so on what you came up to next. So thank you very much.
Thank you,
Oscar Marco from the Director for Innovation and Collaboration with Industry at Biosense Institute. And yeah, I think I wasn't the only one quite amazed with the presentation. Thank you very much, Oscar. Next, we are not waiting. We are moving forward. Next, we are going to have our teamwork. We will have a little bit less time for it when we planned, but I think that's okay. Usually, we did this once before, and I think time was not a problem. So now we are going to have discussions in the breakout rooms. You don't have to do anything. You are going to be automatically separated into some smaller rooms, let's say inside the app, and each breakout room will have a mentor appointed, who is going to guide you through the discussion. And basically, the discussion is to get to know and to understand what do you have to do with robots. Maybe you have some good practices of robotics adaptability, or maybe elements of it, and you maybe can share it with us. Maybe you can share the challenges that you're facing in the adaptation of robotics. Maybe you have some solutions. So that's what everything is about. So it should focus about your knowledge and your good practice, and how do you make the solutions in robotics in your workplace, in your business, and so on. So yes, we have 4 moderators, and you are going to meet them soon in the breakout rooms. After everything, we'll have a 10-minute break, coffee break, maybe a 5-minute coffee break, and the moderators will come back to the main room to present the results. And also we have going to have one more presentation. So now let's all jump to the rooms. I'll be one of the moderators. So see you there. And we have a bell. That's nice. So welcome back, everyone, after the break, and thank you for your work in the team groups. Now I would like to ask the moderators who've been talking with you to join me, and let's discuss what we heard and what was the talk about. And we have 4 moderators, including me. That is Diana Shalkauskienė, project coordinator at Agri-Food Lithania, DHI, and Dr. Valdas Rapševičius, head of AI at Art21, and Dr. Martynas Velička, physical science leads at Art21. So let's connect all of us. A moment, then we'll be, yes, Diana is connecting, and the other ones hopefully too. Valdas is here. Hi, Valdas.
Hello, Lucas.
Hi. So, and do we have Martynas joining us? Yeah.
Hey,
Hi,
I'm here.
Hi, good to have you. So, okay, can you maybe each of you present shortly what were you talking about in your rooms, and then we can discuss. And maybe if anyone has any questions, you can write it in the chat, or you can raise your hand and join the discussion. So, who could go first? Valdas, can you tell us?
Sure. So basically, in our breakup room, it was me and Oscar who were discussing and spreading ideas. It was an interesting discussion actually between us. We were mostly thinking out loud and just talking about the things that we have encountered and experienced already with applications of robotics to agriculture. Basically, Oscar obviously had more experience with this because of his experience with farmers directly. As you have mentioned, I am mostly AI lead. So basically, I'm a lab guy who's sitting in a lab and developing some innovations, not contacting farmers directly in most cases. So it was very interesting to hear from Oscar's experience. So basically, one of the points that he mentioned immediately was the experience with robots presented to farmers, and farmers actually learning from other farmers, not from the guys who are showing robots.
Yeah.
So this is peer-to-peer learning, which is the most influential. Sellers are farmers to the farmers, so that's very interesting to hear.
And this is happening where?
Maybe Oscar.
Yeah, well, that's my experience at least with working with farmers, because if I'm telling them something and if I'm trying to persuade them to use some kind of system, that's not going to work. But we need to have some sort of influential farmers. So it's literally that you need to have Kim Kardashian's and Paris Hilton's farming on your side. So once you have them, then it's easier to scale these technologies across the community. Because, coming from engineering, coming from research institutes, I'm not a member of the community, or at least I'm not perceived as a member of the community. And farmers have been tricked a number of times by the states, by the banks, by insurance companies, and they are quite reluctant to engage in any kind of collaboration and to invest any money, time, or any effort in some things that somebody is just telling them that they're going to work. So I think that we need to change the approach here.
Yeah, and do you often have to approach these Kim Kardashians or farmers? Is it easy to find them?
Yes, but they're quite hard to find, and you need to really understand the local community and the local ecosystem. So, who is this guy that everybody believes? So, for example, in one county here in Serbia, there was this guy who is an owner of distribution of fertilizer, for example, and farmers, they come up to him and ask, so which fertilizer do I use? And he then tells them, he's like like a doctor for the fields, and he asks them, so what did you plant? When did you plant it? What's the problem with the crops? And then he would tell you, like, use this kind of nitrogen fertilizer in this amount, and everything is going to be fine. So, but these people are not really that easy to find, and you need to really understand things on the local level.
Yeah, but then everything moves faster, I guess, once you find someone like this and can connect. Great, well, so you were two of you, right, in the room with Oscar. Okay, what about the others? Diana, what were you talking in your room?
We were together with Martinez in our room, and basically we talked like Valdas talked with Oscar, we talked with Arthur, and we did talk a lot about actually data protection and data protection issues and how people. For me, it was very interesting that point that Arthur brought, that at first people were not even aware of any issues that robotics can bring. Then everybody were very afraid of this data issue, the data protection issue, that they could, someone could collect their data, sell their data, and so on, so forth. And then the regulation came, at least from European Union, and now everybody are like tired of it and not even consider that an issue. Everybody is just so used to it, and even with I guess the people just accept the technology and think about this data issue before applying the technology, and when they are, having it, it's not an issue anymore. So that was interesting take out from me, but maybe Martinez has something to add.
Yeah, so as Diana already told, we talked a lot about all kinds of issues, I guess, starting from Roomba data collection and selling it to Chinese government, and ending with AI applications in the high courts. So I think for me, most interesting issue was that, as Diana mentioned, the awareness of the end users is too low, in my opinion. They just don't even consider what kind of data, what kind of ways the data can be used, for example, to make a profile of the person. And when the GDPR law came, so everyone was kind of thrown into the pot all at once, and they started to understand more about the issues that arises with the personal data gathering. But then, and I share that from my experience, the users got really tired because it was made hard for the users to deny the cookies, for example. And what Arthur really brought a good point, that we can make all sorts of regulations, but it's really hard to enforce them. And we don't have the tools to enforce the regulations to all the companies and all the algorithms that are made, updated, as Arthur mentioned. And so we tried to come up with some sort of solutions, I guess. So we had one solution I think kind of agreed on. So if the users could monetize their data, I think it would be much more applicable for them, much more they would, let's say, won't have an issue, as much of an issue as for the data gathering. But finally we ended with the notion that Arthur brought, is that is it even possible for a person to willingly sell his data? We had a comparison as to a person willingly selling his kidney or something like that. So is it even possible to sell the data willingly?
Yeah, but if it's also fair to compare it with a kidney, your data.
Yeah, sure. But
a lot of people would disagree. There are some who don't care about it at all. There are some who care.
Yeah. So I think.
Yeah, and regarding what you told, like, definitely that data management and where does the data go and who owns it after the farmers use much more technology. It's a broader topic, I think, an interesting one. Also, just to mention, I think it's an interesting fact. You talked about who is going to implement the laws, and European Union has a lot of laws, and sometimes they are being criticized because, for example, GDPR, it's not being exercised too much. Just the two laws that I mentioned earlier today, if you were in the beginning, I know because I was following the topic now for a few weeks closely, the Digital Markets Act and so on. An interesting thing is, I think it's the first time I saw it, and the first time I've seen it is that the European Union is planning to put a cost of a 0% of early revenue for the big technology companies. So they would pay for actually European Union to exercise the new laws that are going to, basically they're going to watch over the big technology platforms like Google, Facebook, and so on closer. So European Union is counting that they will need around 230 new workers who could just follow what these, let's say, 6 companies or 5 or 6 or 10 big companies are doing, and they are going to take the money out of their pocket, of the revenue of themselves, to actually monitor what the technology companies are doing. This is something that I think we haven't seen before. That's not that common, maybe. Arthur has something to add. Maybe I'm wrong. So Arthur, sure. We cannot hear you yet, Arthur. Something is, your microphone is on, but can you? Not yet. Not yet. Something is. Don't worry, it happens. Don't worry. We will wait for you. And no, not yet. I guess you have to open the settings and change the microphone that you're using. I would guess that's the thing. That's usually the problem. You go to the open settings on the right top and change the microphone. No? Let's wait for Arthur for a moment. What about now? Arthur, can you hear us? Can you say something now? Well, I would love to hear what Arthur has to share with us on this one. Maybe it's something that I said. Maybe it's not the first time this is happening. Anyway, he should know better, I guess. He's a professor at the Warsaw School of Economics, so maybe he's following the discussion closer. Arthur, yeah, maybe you can write it in the chat since we cannot hear you. Okay, thank you. So we'll wait for Arthur to comment on this one. Yeah, and meanwhile, I'll share what's happening in my room. I had Vilimantas. There were 2 of us. So we were talking Lithuanian. I actually got to know a lot about drainage systems, which I didn't know anything before. And Vilimantas is an expert in that. He's actually at the moment is looking for funding to his technological idea of monitoring all the drainage systems and finding them using drones. And he's interested in robotics, so we talked a little bit about the technical side. But I think he had a nice idea that, when I asked him about the implementation of robotics in agriculture and if it's happening slow and why is it so, he said, well, the Rome wasn't built in one day either. So that sounded quite positive and just explained a lot that, you know, the technology is here and we need to wait a little bit more. And if we also find the Kardashians of farming, maybe it moves it forward. So that's something we talked about shortly. And I guess there were less of us in the rooms when we anticipated. So we are not going to take much longer on talking about what we heard. Does anyone has anything to add? Valdas, Martinas, Diana, what you heard? Would you like to share any good practices that you heard of?
Yeah, so we basically, Foster, we have discussed mostly one issue is, again, just like you did, Lucas, is how to sell actually robotics to the farms, how to facilitate their adoption of robots into farm. And we had a few ideas more, which I would like to share, is that risk of taking the innovation into the farm might need to be shared between the innovator and the farm in order not to fail the farm alone, which is, we find, one of the key points. And that improvements into the farm need to go gradually, not drastically, not fundamentally. Just like we had an example where the GPS and automatic tractors are very well adopted in farms, because this is a slight improvement of already existing equipment. But drones is something completely drastic and fundamentally different than currently is employed in farms. So gradual improvements might go better into the farms and might lead to overall optimization of the work at farms. So this is, we found good points in how to get robots into the fields.
Great, thank you, Valdas. I just want to read out loud the Arthur comment that he had. The comment was that without the algorithmic enforcement, we cannot really effectively enforce regulations targeting tech companies. DGA, DMA, GDPR, etc. can all be prepared with the utmost care, but are a little match for the technology. So shortly, if you regulate technology activity, also use technology. Thank you very much, Arthur. I think we got the idea, and yeah, I can only agree. And okay, so thank you, everyone. Thank you for joining me. Thank you for the short presentations of what happened in the breakout rooms. Let's continue with our last presentation of the day, after which we are going to have some more evaluation questions, just a few, and we'll finish off. So thank you all the moderators. Now we are going to have Dr. Soren Markus Pedersen, Associate Professor at University of Copenhagen. He is going to talk about social impact of robots, experience from Robots for Crops project. So super interesting to hear what is the set case about. Hi, I can see already you.
Okay.
Soren, hi.
Can you hear me?
Yeah, we can hear you. Hi, good to have you here. How are you?
Yeah, I'm fine. Thank you for giving me the opportunity to say a little bit about our experience from Robots for Crops. I guess before I start, I have to share my
yeah, let's try to do that.
So maybe I hope that it will work okay, but I start now.
It will. Let's see. Yes. Yeah, it's setting up. Just a moment. Yes, we can see it already.
Can you see it as full screen?
Not yet. I think you just need to press on the presentation. I mean, we see the full screen of your screen, but not the PowerPoint itself.
Hello?
Hello, Mark.
Can you
hear us? Yeah, we can hear you. We can hear. We can see our screen, but it's not on full screen mode yet.
Hello.
Maybe you should share the whole screen in the screen share settings. Try to share the whole screen instead of the window.
Can you hear me?
Soren, yes, we can hear you. Let me write you a message. I think we can hear you, Soren, but just a moment, everyone. We'll fix it.
But can you see my PowerPoint now?
Yes, we can see it. It's just that it's not full screen. Otherwise, we can see and hear you.
But it seems so when I go full screen. I don't know if you saw full screen just before.
No, we didn't. No, we didn't.
Okay, because it seems so that if I go full screen, then somehow you can't hear what I'm saying. Or
really? Let's maybe try it out one more time, because
if I try now to make it as a full screen,
we can
and then see if
I
try that.
Soren, maybe you should try sharing the whole screen instead of the window, because now we cannot see the slide share. But if you would share the whole screen, I think it would work.
I can't hear you anymore.
Okay, Soren. So it looks like when you share the screen, we lose the sound. Let's try once again. So, Soren, can you hear us? Can you hear us now?
Okay, now I returned from full screen.
Okay, Soren, we can hear you.
Maybe just present like that. Yeah.
Yeah, let's do it like this. It's okay.
Is it okay to do it like this here?
Yeah, let's do it. It's quite big, the screen, so we can see it all. So let's do it this way. It's okay.
Okay, perfectly. Okay. Well, thank you for giving me the opportunity to say a little bit about ROPS for crops and the experience that we have from this project. Briefly saying, my name is Søren Markus Petersen. I'm from the Department of Food and Resource Economics at University of Copenhagen. And we, together with my colleagues, Siganesh Tamira, Jens Erik Ørum, and Sune Hannibal Holm, we are involved from our department in this project called ROPS for Crops, which is a European project financed by the EU, dealing with the use and implementation of different kind of robotic systems on 4 different sites in Europe. I'm not going to go into all details about the whole ROPS for Crops project, but the objective of this part that I will say a little bit about today is to assess the social impact and farmers' perception of selected systems in the pilot cases in ROPS for Crops, and also to outline some of the concerns and barriers that farmers have about using robotic systems on their farm. The overall, objective of this work package, which is work package 7 that I'm work package leader of, is to look into the economic impact of using the robotic systems at these 4 different kind of sites that we have in Europe. And these sites are located in Holland, the Netherlands. We have one in Spain. We have another site in Greece, and we have a site in France, in the area of Angers, in the Loire Valley. In the Netherlands, it is focusing on. It used to be focusing on potatoes, but now they have changed the research area, or the trial area, to pumpkins with mechanical weeding. In France, it's focusing on vineyards, wine production. In Spain, it's focusing on orchards, in particular apple orchards. And in Greece, it's focused on application or spraying in table grapes. So it's 4 different kind of systems, and I would say that 3 of those, research areas, they focus on, single use or targeted use of the robotic systems, either for spraying or mechanical weeding and so on. Whereas the robot is designed as such. Whereas in the Netherlands, it's focusing on a tool carrier. It's based on using a robot named Agri-Food that has been developed here in Denmark. The robot is called Robotic, but it's developed by a small company called Agri-Food, and that's more like a tool carrier where you can carry on different kind of tools on the robot. It's also driven by a diesel engine. So these are the, how can I say, this is the background that we are looking into these different sites, and we then try to see how can robots be implemented on these sites in a reasonable way. And also as a part of that, we have a work package 7, which is dealing with the economic impact, but also looking into social and also ethical impacts of using these robotic systems. Right. So far, what we have done is to make an assessment, and it's based on so far about 40 farmers have been given response to these questions that we have asked them for in these 4 sites. We are still continuing to get data from the farmers, and in this, as it is now, we have not received data from the Dutch farmers. Well, we have received some farmers, but it will not be presented here because at the time that we made this, we have focused on Spain and Greece and France. So we only have data for these 3 areas. Then it is also based on non-farmer interviews with about 14 people, experts on robotic systems, where we have looked into their view on using some of these systems. Briefly speaking, some demographics. You can see here that the mean area in the 3 sites, France, Greece, and Spain, among the farmers that we have asked these questions, is roughly speaking between around 50 and 45 hectares in Spain and France, and between 15 and 20 hectares in Greece. They also have different experience in terms of using or being a farmer, where most of the Spanish farmers has quite a lot of experience, whereas the French farmers have less experience. With this data, we also asked them. We have asked, I would say, quite a number of questions, and I will not address all the issues here. Some of them have also been about technical issues and technical needs and so on, but I will just briefly give an overview of some of the output that we have got from these respondents. When it comes to the current practice and challenges, 78% of the farmers have difficulty to find enough labor when needed. This is one of the key issues that they address. 41% are currently using farm management information systems, whereas 38% have never tried it. It was also to give an indications about whether they already are familiar with using computer systems and farm management information systems and so on. Also, when it comes to the current practice on the farms, 60% of the farmers find that they have some challenge with the soil compaction. And then we also can say about the farmers that 40% have participated. All the 40 farmers participate in field technology events such as workshops, training, conferences, and agricultural fairs, also to give an idea about how well they are, how can I say, networking and interested in adopting new technology and so on. Then if we ask them whether they plan to invest in robots, when asked whether they plan to invest in robotic solutions in the coming 10 years, about 57% said yes, 19% say no, and the rest said, I don't know. We also have to say that these farmers that we have, I mean, as many of you probably also know, that it's not very, I mean, it's very few robotic systems that have actually been implementing on farms and are in commercial use at the moment. And this is also the case for these farmers that we're dealing with here. It's only, I would say, as I remember, about 2 or 3 farmers who actually have tried to use a robot on their farm. So it's basically farmers that are located for these regions that have been involved in the survey. Also, about 66% stated that they do not think they have adequate information and advice about robotic applications in agriculture. So many of the farmers feel that they lack information on that side. And this issue is mostly the case in Greece and in the Spanish sample. if we then ask them what are the motives for using robotic systems, and we said, why would you like to invest in robotics? The three most cited motives or reasons to invest in solutions are to save labor costs, which is 55%, to increase profit, 35%, and also to reduce environmental impact, which is 30% of the farmers who said that. And when it comes to the fascination of the technology, it's relatively few who see it as a particular fascinating. I have previously been involved in dealing with the adoption of precision farming systems and so on, and we also ask these type of questions about whether they find it fascinating and so on. And I would say it's more or less the same thing we see here, that farmers are very much looking on how can they make use of the systems and are not that particularly keen on whether it's fascinating or so to use. Then we also addressed questions about farmers. We also addressed questions about whether farmers, what are the farmers' concern about these robotic systems, and one of the major concern is the high investment cost related to conventional practices. Safety and reliability is also a concern about many of the farmers. Then we have quite many farmers also see the problem about how it can be adapted to small farm sizes, which may be a little bit surprising because many robotic systems are at the moment also developed or designed for relatively designed as relatively small units and also for use on small farms. Ownership and the privacy of data and so on is not a huge issue that has been discussed among the farmers. And also when we come back to some of these how can I say non-farm stakeholders, when we asked the experts, which were representing universities, supply companies, manufacturers, and so on, from who are involved in developing robotic systems, they also their view was also that the ownership data and privacy of data and the ownership of data was not a huge concern among them as such. Yeah. Then there was also a few farmers who had problems with the low driving speed of the robots. And there was also a few farmers who see a problem about whether, and that was especially in the French case, whether consumers would have a problem about using or consuming products that has been produced by a robot. And that was in particular in the wine production, in the sense that could there be any consumer reservations about drinking wine that has been produced by a robot. So that was also an issue that was brought up. Then when we said what are the most frequently chosen features of the robots, definitely one of the key issues was that it has the capability of working longer hours. That was a priority among the farmers. Also something about that it could accommodate several attachments, could perform under different weather conditions. Again, a priority was also that the safety of the farm of the robot should be at least as good as what we see with the conventional machinery and so on. We also asked some questions about where they see a potential, where the farmers expect to see a potential impact of robots on selected indicators. And if we take out some of them, we can see that they expect that crop yield can increase by using robots. They also regard that crop quality could increase, at least some of them or most of them. They also expect that they can increase the gross margin by using robots, and that also leads to the net profit and so on. And then when it comes to, for instance, soil compaction, they hope or see that the robots can reduce the soil compaction, and that could also be related, for instance, to the yield. The fact that small units can reduce soil compaction and also by doing so, in the long run, it will be capable of increasing yield with reduced soil compaction. That is a view that you see in some studies as well. And then obviously, they see that the labor demand will decrease by the use of robotic systems. So these are some of the indicators that they pointed out. In line with these, how can I say, descriptive statistics that I just presented here, we also interviewed non-farm stakeholders on their view on the social impacts, and what they say is that also what we expect, or what we see from the farmers' point of view, is that they expect the robots will save labor and reduce these many repetitive tasks that we have on the farms, and this is a benefit from using the robots. They also have a little bit about concern, or many of the non-farm stakeholders address the concern about disruption, that some farmers will be left behind because of the also the knowledge and the skills that they have that they need to actually to use the robots. But it was also quite clear from many of the experts that they see that robots will enable the better use of precision agriculture management. So they see that robots will the fact that you can use robots also for collecting data, for collecting information with sensors and so on, that it will enable the farmers to perform precision farming better. Then there are some concerns that robots will move jobs from rural to urban areas, and also the fact that farmers will have to get used to new working routines. And they all see some challenges in terms of reliability of the robots. We already see from the Robots for Crops project that there is still a lot to do in making sure that the robot drives in the right directions and so on, and that the software is reliable and so on. And obviously also the safety issue is a concern among many of the stakeholders. And then, like with the farmers, there is they need to prove that the benefits are higher than the cost of using the systems, and that these systems are profitable under different conditions. And then there was also a key concern about the logistics of using the robots compared with conventional systems. Also the fact that if you have many small units and you have to make sure that these units are available to do the task at the right time during the season. This was really a concern that was brought up by many stakeholders. So based on that, you can say that these are just a few recommendations that we highlighted from this. It was a deliverable report that we made to this project here. We came up with these recommendations for the further development. Is that when you develop robots, you should consider how the robots should be designed. And as we see it now, there seems to be some kind of a dilemma between robots that are, how can I say, more like a tool carrier system, whether it should be developed in that direction or whether it should be a targeted robotic systems for specific purposes. We have an example of the Agri-Food, which is a tool carrier system, like for instance a normal tractor where you can mount different kind of equipment on it, or whether it should be a more targeted system where the robot is only designed for spraying, seeding, or whatever. So there is a kind of a mixed understanding, if you can say so, which about what direction you should go into. Then we also recommend that we have a focus on these short time windows for solving specific targets with small units. And this could create a logistic problems, and the whole logistic about moving robots from one area to another is important to address. Then there is also something about that you should make some considerations about how to store the data for documentation later on. And also there was a quite clear message, at least from our study here, that both among the non-farm stakeholders, but also among the farmers, that control of data should be carried out by farmers. And as long as the farmers have some kind of control of the data, there was not a big discussion, at least not in this study here, could be in other studies, but at least here, there was not a big discussions about how, about data protection and so on as such. And then obviously also the safety regulation is important, and the whole legal issues about these issues. For instance, the whole problem about how should a robot be monitored. We know now, at least where I come from here in Denmark, that, and also in the EU, that the regulation is not very clear about how to use the robots on the field and how it should be monitored. It still follow, in principle, many of the, how can I say, the basic rules that are given in the machine directive in the EU, and many of these regulations are outdated, and we also know that the EU works on developing new regulation on that. So this is an issue that should be followed up on. And then also there is a clear need for training and education at the agricultural colleges and schools and so on for better use of the robots. And then the last recommendations from this study we came up with here was to consider what are the consumers' concerns in regard to the food produced by the robots. So these were some of the recommendations, and you can, if you want, have more information. Basically, you can just write ROBS for crops if you search on Google, and then you can go into the website that we have, and these are some of the partners you can see here that are involved in the project. It's led by the project that is led by Wageningen University, who are the coordinator, and then we have a number of partners in different areas in Europe. Okay, that was what I had to say.
Yes, and it was great, Søren. Thank you very much. It was a great overview of everything that we talked about in this event today. I was wondering when you were talking, since it looks like you are the one who has a lot of insights of how the farmers feel about robots. So how long have you been working on these issues? How long have you been monitoring it? And how?
Well, I guess that robots is a relatively new thing in agriculture, but we actually started to work with it because we had at my university we had a visit of a professor named Simon Blackmore. He came here to our university around 15 years ago, I think, and he's very much interested in robotic robots and so on. He's now retired, but then came back to UK and so on. But at that time, we did some studies together, and we also tried to make a first feasibility study on using robots, together with him and other colleagues. So I have an interest in it, but I would say my main interest over the years has been about the adoption and the economic impact of using precision farming systems. Like site-specific application of fertilizers, auto-steering systems, and so on. And with this, which has been my main area, if you can say so, then I have slowly also started to get interested into autonomous systems in the agricultural sector. So now we are involved in this project, ROBS for crops, and I'm also involved in two new EU projects that is starting up now, which also address smart agriculture, not in particular, I would say, robotic systems, but areas that are close to that, and to see how you can develop some sustainable solutions in agriculture. So one is called Beetles, and the other one is called D4Ag Ecole, that are starting up here now, actually. So yes. Yeah.
I'll just put the website, your website, in the chat for everyone who wants to visit and know more. So thank you very much, Søren. I'm wondering, is there any more questions for Søren about his presentation, about what does he do? It looks like no. So great. It was great to have you here. Thank you for a wonderful overview of everything that you talked. So
okay.
Thank you very much, Søren.
Thank you very much. And
thank you.
Have a good.
See you next time.
Bye-bye.
Bye. So sorry, did really put a lot of dots on the I's in what we talked in the beginning. This is the end of presentations. Now we are going to have a very short overview of the whole workshop, just as we did in the beginning of the event. So I would like to ask you once again to answer a few questions from the survey. Some of them are going to be just very quick ones with where you can choose the answer, and some of them are going to be evaluation questions about the maturity assessment model. So let's jump right in. The first question is, technological progress is more important than social progress. So that's not a question, that's a statement. Do you agree with it or no? We would like to hear from you. Let's do it in a quick manner. Do you agree or do you disagree? I remember the answer from the last time. Let's all vote. Yeah, Carolina, thank you for your compliment, and Isaac and Nesta, I can see you in the chat for your compliments. I can totally agree that the presentation was really, really good and to the point. Okay, let's see the results of the first question, and yes, can we do? Yes, disagree is the same as before. Okay, the second question is, I believe that various aspects of robotics are discussed sufficiently in the public discourse. Do you agree or you disagree? Let's vote on this one. Let's all do the voting. And let's see the results. And the most popular answer is, I can see it's disagreeing, not knowing the various aspects of robotics. Let's see the results of this question. Can we see the result and the answers? Yeah, most of you disagree. It's not discussed sufficiently. The third question is, statement, I believe I am aware of the main non-technical issues that the robotic industry faces. So are you or are you not? And this event might have changed this answer. I don't know. At least I feel after the whole event that I know a little bit more than I knew before. That's definitely true. What about you? Okay. And let's see the results. The most popular answer is agree, just as before, as I remember. This workshop helped me improve my understanding of the issues robotics face. And you can choose the answers this time, they are different. This was new to me, significantly, moderately, slightly, or not at all. So you can choose the magnitude of how did this workshop help you to improve your understanding of the issues robotic faces. Okay. We have different answers. Let's see the results. Significantly, which is nice to hear. It helped you to understand the issues robotic faces. This was new to me, also quite popular. So this is quite nice to hear. Okay, then we have a few more questions about maturity assessment model evaluation. So let's move here. I think there is a need for a tool for assessing the maturity of robotic solution and its suitability for adoption. So that's something that we talked about in the beginning, the maturity assessment model. The organizer wants to know your opinion about it. I think there is a need for a tool for assessing the maturity of robotic solutions and its suitability for adoption. So a universal tool to do so. Do you agree or you don't disagree? Or you disagree, sorry. Yes, I can already see most of you agree with this one, that we do need, there is a need for this kind of solution. Okay, we have the popular answer is agree. The second question about it is, who should be doing the maturity assessment of the robotic solution? Who should be responsible for doing it? And you can type your answer in the chat box, and then you can see, of course, the other answers. Who should be responsible for taking care of this solution? Who should be doing it? I don't want to slip you the ideas, so you can just put whatever you like. But of course, it can be, let's say, how I imagine it can be producers, it can be, as we can see one answer, European Union, it can be a developer, of course, the governments, or should it be the farmer union who does it, or European Commission? Do you know the idea? Government institutions, yeah, one of the answers. So who should be responsible for it? Yes, in the market economy companies developing the robotic solution, definitely in interdisciplinary teams. One of the questions. Okay, let's see the results. Hopefully you already had some time to vote. But I can see already that some of you voted for government institutions, and some of you say that should be made by in the market economy, should be made by companies developing the robotic solution. So I get your idea what are you talking about. Next question is, who would be most interested in maturity assessment tool? So who should be the ones to have interested in it? Let's type our questions, our answers. Who should be the most interested in the maturity assessment tool? Yeah, let's vote for the answers after you put yours. Some say it should be the most popular answer right now is the end user. Also, some are saying that all should be interested. Some saying the government should be interested. Or yes, the most popular answer maybe is the robotic solution developers and companies. So okay, so that's different opinions on who should be the most interested. Is it the end user, or is it the companies creating it? We have both opinions, quite popular. Thank you for your answers. We have two more questions left. What are the most important issue areas? Sorry, what are the most important issue areas should the robotics maturity assessment model take into account? So what areas, and we talked about these areas earlier, should the robotics maturity assessment tool model take into account? What it should think about, what should it talk about? Let's type our answers. I'm doing it too. Okay. I can see you submitting your answers. Interoperability. I just want to check if I know what this word means. I think I know, but I'm not sure, so I'll just check it out. The ability of computer systems or software to exchange and make use of information. Okay, yeah, I got it. I got it right. APIs and so on. What are the most important issue areas should a robotics maturity assessment model take into account? That's a good one. I'm waiting for this one too. Interoperability, so different kinds of systems can work together. Looks like this was a hard question. Yes, I can see from your answers. It takes some time to answer, which is okay. We are still waiting. Some are open to say they don't know the answer to this question. Looks like this is a hard one. Hard to think of or hard to choose. I don't know. Tech development and legal issues, education or cultural, meaning EU regions, and social impact to farmers and local communities. Okay, let's finish with the question. So interoperability is the most popular answer, and for me it was an unexpected one, but I think it's a great insight. Let's do the last question. And the last question is, what are the least two important issues areas should robotics maturity assessment model take into account? So the same question, just vice versa. So what are the least important issue areas? That's also a hard one. Okay, I'm not the only one struggling here. It's hard to say what is the least important. Okay. Who is brave enough to go first? Okay, we have one answer. Okay, we're talking about not something that is not important at all, something that is less important than the others, that you think shouldn't be taken too seriously. Let's write our answers. Yeah, and we agree, some of us agree that we don't know really, it's hard to say. But some other answers are costs, okay, ethics, and agriculture and water management. Okay. Costs and profitability is the least important issue that should be included, taken into account. Okay, I think we can finish with our questions. It looks like the end of it wasn't too easy, right? Since the most popular answer, we have a new one. Let's see which answer is the most popular. It's costs and profitability. Okay, another popular answer is I don't know, which is very honest. So thank you for your honesty. And thank you all. Thank you for joining us today. That is it with the event. I think we enjoyed the great presentations, which were really overviews of the whole thing, of the social impact and acceptance of robotics. I think the speakers are the ones who are really into this field and could tell us a lot. I made quite a few screenshots about it. So thank you all. Thank you very much for joining us. I hope you had a good time. Hope you learned something new. And on behalf of me and the organizers, I would like to say thank you. If it was a good time, you can maybe say something in the comments. You can say bye. You can make a wave. How to make a wave react? Oh, I can. Okay, on fire. I'll do this one. So Diana, you want to say something for the finish?
Just to thank everyone for the great workshop. I really enjoyed it. The presentation were really interesting, and Thank you for your patient collaboration and answers to the questions. Yeah, thank you so much, and have a nice day. It's beautiful weather today, so
Yeah, I'm bombing with the reactions, the chat. We'll see if I can hack it. Okay, really great time. Thank you everyone, and yes, have a good lunch and see you maybe next time. So thank you everyone, and bye then.
bye.
Bye bye.